method, and this is this answered a lot of questions. I saw this and I didn't understand it until I read your book. So suppose you have a hash function, like MD5, for example. You start with the word, you hash it, then you hash the hash, then you hash the hash again. So if you're trying to evaluate the quality of a hash function, my first thought is you would just have like input, like 1, 2, 3, 4, 5, and hash all of those and try to see if you find a collision. This turns out to not be the most efficient way to test the security of a hash function. That would seem like the obvious way, but this way is better. And the reason is, if you choose this series of inputs, I start from something, then I hash the hash, then I hash the hash, then I hash the hash, it'll just keep moving. Eventually, you will find a collision where something hashes something else. And when you do, you hash this and it gives you a number you've seen before. Now you're in a loop. It'll just go around this loop forever. This is why they call it the Rho method. This is like the Greek letter rho. And this turns out to be the computationally most efficient way to find the collisions in a hash function, because there are tricks. The simplest case, you would remember every hash function, and every time you calculate a new one, you look through the whole list to see if you collided. But since you're going to be going around a loop forever, you don't really have to. You can just remember a small number of the hash functions, like the ones that end with many zeros, and then wait to see if you see that one again. Because you will, because you're going to go around this loop forever. So it turns out that in practice, this is the technique used to test hash functions. So let's play with it. So use Python, and you can use any Python library. Like I suppose I might do what students do here and use Colab.
I don't understand. Why you don't have to store all hashes in
You would remember all hashes, and that would be best. But if you have a big hash function, that would be too many. Like you make 2 to the 64 hashes, you can't remember them all. So you could really remember only a very few of them, and you'll still see it come around again.
Yeah, but what if we just remember we know.
Because you calculate a hash.
Outside the circle, right? And we might remember all the outside hashes.
That's right. Yeah. You don't. These you can remember, they're useless. You want to only remember the ones in here, but you don't know where the circle is.
You don't know where the circle is.
Yeah. That's so you have to have some way of remembering. And so what you do is you can ignore all the hashes except the ones that end in 4 zeros, and wait for one of those to come around again.
What if they don't come around?
It will eventually come around. It has to, because you just go around a loop. Unless you're so unlucky that not a single one in here passes that test. Okay, well there, you can use the size. And the rule is the length of the tail is approximately square root of n, and the length of the circle is approximately square root of n. So you know, that's right. That's an important secret. That's the rule. The rule is if you have a total of n possible hashes, this will be the order of the square root of n, and this will be the order of square root of n. These are important facts. Good. You're right on target. So I'm going to use Colab because some students might use Colab, and I mentioned it. I added it to the 105 project. If you don't have a Python install handy, you can just use Google Colab. So I copied, whoops, that's not it. I thought I copied it. I'll copy it now. So that's why I say you don't need to know much Python. You don't really need to have a local Python install to do this stuff, although for the advanced ones it helps. So here, I import hashlib and I calculate the hashlib. This is the way MD5 hashes are calculated with hash library. You calculate the MD5, and I'll use the letter A as my password, and code it as ASCII, and hash it, and then I'll use the hex digest. So if you do that, it's connecting, initializing. Okay, now it's done. There we are. There's the hash. So that's an MD5 hash, 0cc and all that. Let's see if it matches my expected value. 0cc. 17.5, okay, so that's the MD5 hash of just an A. So I've now got a hash algorithm. All right, now I'm going to truncate the hash. So let's try this one. I just add a bracket -2 to the end. I can just do that. So this whole thing is a hex digest. Okay. The hex digest is a long string, so you can do :2, and that will give me just the first 2 characters of it in Python. So it should be CC. Yep, there it is. All right, so now I got 0C though. Maybe that's right. Let me see. It is, wait, I'm getting 61 because I used an A. Oh, I wanted the 2 on the right. Okay, get the 2 on the right, it's -2 : Okay, that's the first 2 characters, but I wanted the last 2 characters. That is -2 : All right. Now I should get the last 2, which are 61. Okay, so I've just made 8-bit hash by taking MD5 and truncating it, just a handy way to create an 8-bit hash. So now I can do iterated hashing. And this should do the job. This will be, for a very simple small hash function, this should give me 50 hashes, and there they are. So now I got 50 hashes, and all right. Now I'd like to put them in some environment that wraps them around, and I don't quite know how to do that in my browser, so I'm just going to copy it and put it in a text editor.
You can put new lines in it.
You could, but I want to vary the new lines, you're going to see. So if I go here, you're done with this one, and put them here, see what I want to do. It's not, all right, let me try copying it again. Oh, what, oh, copy, all right. There we are. See, I want to find out where it duplicates, and I'm going to do it by varying the width. So I'm just going to look for stripes here. There, right there. A2, C0, C0. That's why being able to vary the width is helpful. So this is just how I visually find the collisions. There, A2, C0, A2, C0. So this is in the loop, the 98, D7, 79, 1E. There's the start of the loop. The 1E, this E is, so this is the loop from there to there. And it just goes around and around and around the loop. So it's a 256, it's an 8-bit hash function. And how big is this? It's 4, 8, 12, 13, 14, 15, 16. So it was about 16 for the tail and about 16 for the loop. And that's what I said. It'll be approximately square root of n for the tail and approximately square root of n for the size of the loop. So it took us this far to get in the loop, and now we just go around and around the loop. So that's the 8-bit row. And there's just some flags to find by doing longer ones. You start with a different value. You start with password instead of A. You'll get a different hashes. And then you can try it with 3 characters. So let's try that one. To make 3 characters, let's go here. If I want 3 characters, I go here. All right. Now it's going to take more. 3 characters is 12 bits. 2 to the 6 is 64, so I expect it to take about 64 to get in the loop and about 64 to go around the loop, so 50 is not going to be enough. I better get like 200. So let's get 200 of these. All right. Now I'm going to copy them and put them in here. And I might still be able to do it with this technique. It looks like it's not too bad. I just try changing the width until I see things duplicate. I'm probably going to have to shrink my font. And
We can add some more, maybe I can.
yeah, if I had a wider screen or something, I might be able to do it. I just wonder if I might get lucky. Someplace around here should be. So you could try this technique, and eventually you'll see duplicated numbers. But at this point, you probably want to use a programmatic technique. So you'd have to modify your code to remember them all and see if you're seeing a duplicate. And so you have to make a Python list and stuff. You have to do a little bit of Python to get there. So that's why, but this one you can in fact do that way, find the first repeated hash value. Another way to do it, I think I can do this. Since I think it's repeating 36, I know what I can do. I can use the search function. That's a simple answer. So if I believe that it eventually hit a loop, then I take the last number, let's make it big again. All right, 36E, let's just see if there's another occurrence of that. That's right, find 36E, there. And there are 5 of them. So let me just make my thing fit on the screen again. This will be a simple answer. So there's one, there's another, there they are. Okay, so there's the loop. And now I can find where the loop stops. So this is a reasonable way to do it. All right, so that you can do it without writing a code this way for 3, but the next one, you make a 32-bit hash. And that, you're not going to be able to do it this way, because it's going to be, 32 is 4 billion, so the square root of that is 2 million, or it's 2 to the 16, which is 65,000. So it's going to be 65,000 in the tail and 65,000 to go around, and that's going to be too much to view on one page of a text editor. So you'd have to write code that will remember them and check to see if you have a duplicate. So anyway, there's a few things to play with the Rho method there to understand how this works. And that's what I wanted to show you. Let me stop this recording.